Welcome to this lab. In this lab, we are going to look at smart contract security, particularly re-entry and access control, and how we can secure our smart contracts to work properly. Now, you will have the code for this contract. This contract is being run out of a integrated development environment called Remix, and the URL is remix.ethereum.org. Hopefully you can see that here. And I'm just going to enter that and update the browser. Now this browser is zoomed in quite far, so the text might look might not look like something you're used to seeing, but that's okay. We're doing this strictly for demo purposes. Now you can follow along with this. You can rewind this lab and try it all yourself. So what I'm doing is I'm opening this contract. Its name is payable.sol, short for Solidity. This is all Solidity. The contract name is payable contract. And this can get a little involved, so documenting this can be a little confusing, but I'm going to demo all the steps to running this contract so we can see how this contract is secure. So there are steps in here because contracts are very role-based, and you'll already see some roles here. We're going to have a payer and two vendors, and we're going to pay them using a smart contract. But if we take a look here at the smart contract again, we can see some data structures here called mapping, which I'm sure you've seen before. The contract is very much like a Java class. We have a constructor. We have a vendor, and we have some attributes for the vendor. And we have some functions, which are like methods, where we are going to count our vendors and add our vendors. So we have a vendor count here that we can return. We have a function we can issue our currency or our payments. In this case, it's going to be Ether because we're running on Ethereum. And then we're going to send our payments. So this code may look familiar to what you actually saw in the class. This is using similar code here. The only difference is this code has been secured, and we'll briefly discuss other ways to secure this. So we're actually going to enter some vendors, and we are going to pay them, and we are going to also make sure that our wallets, our Ethereum wallets, have the correct amount to actually make the payments. A little about Remix, if you're familiar with IDEs or integrated development environments. We're on this module here. They call these modules over here to the left. This is where we can create new, download, or open. You see we have some existing ones in here. I've already opened an existing contract. So what I'm going to do now is go to the compile module. So I'm just going to click on this compile module button. And then we see this button right here to compile our code. So we're going to compile it using the Ethereum virtual machine. And that was successful because we got the check there. That's good. This is going to give us a lot of options here for right now. Just follow along. Now we're going to go to deploy. So we are using what's called the JavaScript environment, and the JavaScript environment gives us addresses, Ethereum addresses, simulated Ethereum addresses, and it also gives us simulated Ether, and Ether is the Ethereum cryptocurrency. So what we're going to do now is go into the deployment, and contracts are deployed to an address. So we can see here from this drop down, notice it says here the JavaScript VM environment. There are other environments, but we are going to use the JavaScript, and they give us these addresses here, and these addresses are almost always the same. Notice we're deploying under this address, and if you can click copy here if you want to see that address. The addresses are very long. You can see them right here, and sometimes they're very difficult to read. I just try to read the last 5 characters that are in the address so I can manage it better. So we're just going to deploy the payable contract. So we're going to click the deploy button, and that is also a transaction. So we can see here in the output in the console that was successful. We can see the check mark there. And this button right here, the circle, is the clear console. I'm going to clear it just because we're going to refer back to the console. And we don't have a lot of space. And again, I have this zoomed in quite a bit just so it's easier for everybody to follow and see. So we've deployed our contract. And so let's click on that down caret. And let's scroll down. So we have our contract deployed now. And let's click here on the down caret, and if we scroll down here, we can actually see, and I'm going to clear this one more time, we can actually see our how we can interact with our contract. So we can see here the buttons for the methods, the functions, the data that we are building here in our smart contract. So if we look over here, we see add vendor, and we see add vendor, and add vendor takes 1, 2, 3 arguments, and we could either pass them in directly here in this one field, or we can click on this drop down caret. We can see the 3 fields here. So sometimes that's easier to do, in my opinion. We see issue. Issue has 1, 2 arguments, and we can see them both here. So we can use some of these tools to help us just run the contract easier. And then we have some buttons here for returning value. So these are calling methods and functions for the most part. And this is returning some data here. Sometimes there's input. So if we want to balance, we have to add an address. If there's a vendor, we have to add the vendor number. And notice here we have a vendor ID number right here. So let's follow our steps here. So notice we're issuing from this address up here, which ends in EDDC4. So that's important to know. We're going to issue to a certain Ethereum address or Ethereum wallet. So let's go to issue and go to the drop down. And the address that we're issuing to is right here. And this is a long string. So I'm going to copy it and then paste it into the receiver address. That looks right. And the amount that we're issuing, it says here we're going to issue 500. And then we're going to click transact, and this transaction was mined. You can click on this caret all the way over to the right and get some details if you want to. But for now, I'm just going to clear the console, and then I'm going to close up right here. Then we're going to add the vendors. So we have to do some vendor mapping. It's 0 indexed, so just be aware of that. Meaning the first one is number 0, the second one is number 1. So we're going to add the vendors. And if we remember, adding a vendor has 1, 2, 3 arguments. Here are 3 arguments. And we're going to use the ones up here given to us. First vendor is Max. And we have to have Max's wallet address or his public key. That's needed because in blockchain, we need to know the address that we're sending to or your public address. And the amount that he's owed is 300. And then we're going to click transact. And all right, and that transaction was mined. And we can look down here and get some details again. Close it up. And then clear the console. And then I'm just going to close up this add vendor because we're going to see Sarah here has an address. So we've got to open up add vendor one more time. We're going to this time put in Sarah. We have to make sure we carefully paste in Sarah's address, because if we don't carefully paste it in, it's very unforgiving. It's going to tell us it's an invalid address. And then in this case, Sarah's owed 100. And then we're going to click transact again, and that was successful. And again, we can get some data on that. And you can see you can collapse away the console, but I'm going to clear it here, and I'm going to close up add vendor. So we've made our issue, and so now we can see the balance of the issuer. And if we come down here, we are building up a balance right here. So issue balance, we can click it, and it's 500. So that's what was originally issued. So that's what I have in my wallet, and I am the address that ends in FA733C. And if you don't believe me, I can take this address here that ends in 733C. I can paste it in and I can click balance and I'll see it's 500. Our vendor count, we can click on vendor count because we're adding vendors and we have vendor account here. And we know we have 2 because we added 2. And all this time, all these transactions are being mined, but I'm going to clear. And so what we want to do now is we want to pay our vendors. So we want to make sure I have 500 Ether to pay our vendors. I owe one vendor 300 and I owe another vendor 100. So if we come down here, we see the send function, or yes, this is very similar to a method in Java. So we can see here, it's going to loop through and it's going to get the amount owed and it's going to pay that amount owed and it's going to deduct that amount and it's going to increase the receiver amount. So, and it's also going to write some data and manage the balance for us. So this is how we want to make sure that in order to be secure, we go ahead and we want to code it just like this. And we can even hide this, make it almost like a service and have extra data around it. This is a very robust type of language, but as we saw before, there are some techniques that attackers could use. So we just want to make sure the code is solid, just like this one. So this one is reasonably secure. So what I'm going to do now is click the send function, and we should see that the vendors get paid, and my balance goes down from 500. It should go down to 100 because I'm going to pay 300 and then another 100 Ether. So I'm going to click the send function right now. Before I do this, though, I have to change the address of the caller of this contract. So far we've been working with this address, this initial address where we use the deployment that ends in EDDC4, but we've got to change it to the address where we've issued the $500 to. That's important, or else we're going to get errors. So let's go up here to the drop down and make sure we run it now out of this account here that ends in FA733C. And notice I have also this 100 Ether, virtual or virtual Ether for what they call gas fees. Gas fees are Ether that we pay to complete transactions. However, my balance is still 500. I can see it right here. And so I still have that. So what I'm going to do again is we're going to go down here and we're going to run this send function and double check my address again. The address is correct. And that might be the hardest part of this lab, is just making sure that you're running from the right address. So just be aware of that. It's easy to make that mistake. But let's click on our send button. And we can see here that the transaction was successfully mined. Let's click here on this caret. We can go down. We can get some details. We can get some details here. We had a send. And if you look very closely, you can see the addresses in here. And you can see the 300 and the 100 in here. The amounts going up. So this is a log. And the emit here was sending all this information to this log. You can there's a copy button here. You can copy it out to the clipboard and onto some maybe a document where it may be easier to read, but I'm going to clear it for right now. And let's do some checking. So we should see now that the balance, our issuer balance, should be $400 less, or 100, and that's true. That's what happened. That's great. And now we can even get our balance from our vendors. So if we come up here, we need to get Max's address. So let's get Max's wallet. Max's wallet started off with nothing, and now Max's wallet should have, I just pasted Max's address in there. If I click there, Max looks like he should have 300, and that's what Max has. I'm going to clear the console here. And also Sarah. I'm going to put her address in here, And again, you have to do some copy pasting because the addresses are long. So we click here and it is indeed 100. So all of this is in our Ethereum blockchain. So please do rewind these steps, go through the steps in this lab, take a look at the code as opposed to the code that we saw, and just get this working the way that that we would expect. But let's take a look here. If we tried to run this again, so the amount we owed has not changed for our vendors. We can still see here we have 100. So let's try to run this one more time, but now my balance is only 100. Can I continue to issue beyond 100? Think about it. Look at this here and think about it. We always get that the amount here has to be greater than the balance, or else we're going to throw an invalid asset message. So that's important. So we're going to check our balance. So this requirement is key as far as securing this smart contract from payments. And notice again, the amount has to be greater than or equal to the balance of the sender. And that MSG is a special amount here, is a special function here that we can use to get the balance of a sender. So let's try it again and see what happens if we get an invalid number of assets. Let's click send one more time. And oh, look at this. So we do get invalid number of assets. And if we click here, we can look through and see that we get the error, reason, invalid number of assets. So that is how we are securing this smart contract, how we're using blockchain cybersecurity to secure our payment systems. So again, try that on your own. Go through this, enter this in, rewind this lab several times. It's a lot to document. It's certainly easier for you to watch this and go through the steps. It can get a little confusing if you don't see it run and see the inputs. Again, try it, and please do come back to coding boot camps for Solidity training and Ethereum training.